Okay, now we're going to look at the situation where we were in a recessionary gap, and the federal government wants to get out of it, right? So here GDP is too low. This axis is the price level, PL. This axis is Y, the real GDP level. This vertical line is the value of GDP at full employment, also known as potential GDP. In my case, it's 19.35, right? So this vertical line represents the value of what GDP should be for any price level. Because remember, potential GDP does not depend at all on the price level. It is what it is, right? It's the value of output if we're at full employment. This is the short run aggregate supply curve, SRSA, short run aggregate supply. This is long run aggregate supply, and this is aggregate demand. The intersection, right, is right here. The intersection of the upward sloping line, short run aggregate supply, and the downward sloping line, aggregate demand. The intersection gives the GDP level, which is less than potential, and it gives the price level, which is above 15, right? So what I'll do is I'll copy these numbers into Desmos. This is the Desmos I used previously in the previous problem. So I'm going to copy these numbers into Desmos. And I should have an upward sloping line and a downward sloping line. And then I should have a vertical line. Now, because Desmos is a math program and I want a vertical line, I have to use X instead of YP. So I'd like to use YP here, but I can't. In order to get a vertical line, I have to use little x. I'd like to use PL here and PL here, but I can't because Desmos thinks I'm multiplying P times L, right? So I have to use just P's. So this is the price level on the aggregate demand curve. This is the price level on the short run aggregate supply curve. And this is the value of GDP, what it should be if we're at full employment, also known as potential GDP. And then down here, I'm going to copy the demand curve. I have line 1 down here. And when I click on this button right here, it'll turn the line black. And I'll show you why we have equation 4, line 4 in a second, right? I'm going to show you that in a second. Okay, so for right now, I'm going to have that turned off. And if you don't know how to change the colors, click the gearbox here, and you can change the first 3 to black, right? And then change this 4th one to red. Okay. But I'm going to turn the 4th one off, right? I'm going to turn the 4th one off right now, right? Okay, so initially, total federal government debt is $20 trillion. So down here, I'm going to put $20 trillion for government debt. Fiscal budget balance at 0. Right? Current fiscal budget is balanced. That means the fiscal budget is 0. The balance is 0. And I'm going to, let me put the interest rate here. The interest rate is 5.08%. Right? And then the current fiscal budget is 0. Actually, I'll switch these around. I'm going to make that 0. So this represents total national debt accumulated through history. This is the addition to the national debt. Because the budget is balanced, we don't add anything to the national debt. And this down here is the percent interest rate. Okay. Now down here, I give you the real GDP levels, 18.35 trillion, right? That is the intersection of short run aggregate supply, the upward sloping line, and aggregate demand, the downward sloping line. So the first number in this point is real GDP, and it's 18.35 trillion. The second number is the price level, 15.92. And you can see that here, right? So the height of the curve, the height of this point is 15.92. And this is the price level, right? And then it's on the horizontal axis at 18.35. So GDP is less than, I'm going to copy it. GDP is less than potential GDP. Potential GDP, again, is this vertical line made by this equation. Potential GDP is 19.35. It's from line 1, right? So my output gap is a -1. -1 means we're in a recession, right? Because real GDP is currently less than what it should be. And GDP should be 19.35, right? Almost 20 trillion. Again, the fiscal budget is balanced, right? Fiscal budget is balanced. GDP is the economy. The economy is to the left of long-run aggregate supply, right? This is long-run aggregate supply. Short-run aggregate supply is quantity supplied is 18.35. It's less than what should be supplied if we're at full employment. So we're inside the production possibility frontier. So that means the unemployment rate is large or high. And high unemployment means it's greater than the natural rate of unemployment. Now, the marginal propensity to consume is equal to this value right here, because that is the slope of aggregate demand, right? Remember, in our theoretical model, aggregate demand's slope is the marginal propensity to save. So if the marginal propensity to save equals 0.24 in my model, that's the slope, absolute value of the slope of aggregate demand. If this is the marginal propensity to save, the marginal propensity to consume is 1 minus that. So my marginal propensity to consume is 0.76. Okay. So if I'm given $1 of disposable income, tax-free income, if I'm given $1 tax-free, I'm going to save 24 cents and spend 76 cents, right? Okay. Now, because GDP is less than what it should be 19.35, but it is 18.35. What we want to do is we want to push the economy back to full employment. And Democrats tend to propose increases in government expenditures to do that. Now, it can be shown mathematically that the margin that the government spending multiplier, is equal to the slope of short-run aggregate supply it's equal to the short-run supply and the absolute value of aggregate demand. In this case, in our case, theoretically, the slope of aggregate demand is the marginal propensity to save. So if I add these two numbers together, I get 2, right? So down here, I'm going to add 1.76, which is the slope of short-run aggregate supply, to the slope of aggregate demand, the absolute value of aggregate demand, right? This is the absolute value of aggregate demand slope, which is the marginal propensity to save. I get 2 when I add those together, right? But it says I got to divide them into 1, right? So I got to divide them into 1. So when I divide them into 1, I get a government spending multiplier equal to 0.5. Right? So in short, the government spending multipliers equals the slope of short-run aggregate supply plus the absolute value of the slope of aggregate demand. 1.76 plus 0.24, right? Which is 2. And 1 divided by 2 is 0.5. Okay, so that's the government spending multiplier, right? Now, we need to remember that GDP is less than what it should be, right? It should be 19.35, right? It should be 19.35. That's potential GDP. It's currently 18.35, right? So we want to increase it by 1 in my case, right? 18.35 plus 1 is 19.35. So I want to personally increase GDP by $1 trillion, right? Now notice that what we want to increase GDP by equals our output gap without in absolute value, right? So you could actually just get this number from the output gap. Copy the number you have here without the negative sign, copy that, and you can actually paste it down here because that's how much you want GDP to increase by, right? Holding everything else constant. Now, I want to divide the increase in GDP, which is 1, by the government spending multiplier, which is 0.5. So I'm going to do 1 divided by 0.5 down here. 1 is what I want GDP to increase by, and then 0.5 is my government spending multiplier. So in order to get GDP to increase by 1, we need to increase government spending by 2, then hopefully the economy recovers and we're back to full employment. And we got it right. Okay, so we got increasing government spending right. Notice what happened in our graph up here. Remember, the intercept includes government spending, right? It is added to the other numbers in the intercept of aggregate demand, right? And so when we increase government spending, we shift the curve upward to the red line, right? So let's go back to our red line here in part 4. I'm going to turn this on. Notice that it has the same intercept as the black one. What was our increase in government spending? Our increase in government spending was 2, right? So I'm going to add 2 to this. I'm adding 2 to the intercept, right? Adding 2 to the intercept here, right? When I add 2 to the intercept, it shifts my aggregate demand curve up. Notice it shifts it up by 2, right? That's like, yeah, so there's a full 1. You got this little piece right here added to this longer piece. You got 2, right? So it shifts it up by 2. And notice what happens to the output gap. The new equilibrium is right here, and the GDP at the new equilibrium, the GDP at the equilibrium is equal to potential GDP. So we've closed the output gap, right? So the real GDP now equals potential GDP, which is 19.35. The price level is the second number in the point. It's 17.68. The output gap is 0 because GDP equals potential GDP. Right? Now we're on the production possibility frontier. And when we're on the production possibility frontier, the unemployment rate is equal to the natural rate of unemployment. Okay, now here's the tricky part, right? The fiscal budget was 0, right? The fiscal budget was 0. Why? Maybe tax revenues were 5 trillion. If the fiscal budget is balanced, government spending would be 5, right? If I have taxes here, taxes collected by government here, and inside the parentheses, I got the increase, I got the government spending, right? So government spending subtracted from taxes is 0. So the fiscal budget is balanced, right? What do we do to get the curve to shift from black to red? We increased government spending by 2, right? So if government spending was 5, it is now 7, right? So government spending is inside the parentheses here. Government spending is now 7. Tax revenues are still 5. Now we have a fiscal deficit of 2, right? So our fiscal deficit is now, the negative sign means deficit. So deficit is 2 trillion. We don't need the negative sign. Now, running this deficit means we're going to add $2 billion to our debt. Debt is a negative, right? We're going to make that negative more negative. So our new fiscal budget, the government's new debt level, our new fiscal debt level is $22 trillion. Remember, we're paying 5.08% on this last year. We're going to pay 5.08% on it this year, right? So we're going to multiply the 5.08%. We're going to multiply that by the $22 trillion in new debt, or our new debt, right? Our new national debt. And so the interest payment on $22 trillion, the interest payment on $22 trillion at 5.08%, holding all else equal, will be 1.118 to 3 decimal places. So now the bad news is, after we pay this interest on the debt, it's going to be added to. So this is before interest. This is what our debt is before interest next year. When we pay the interest, our debt is going to go to 23.118, right? Now, in review, GDP increased by what? GDP was 18.35. It is 19.35. That difference is $1 trillion, right? We wanted to increase GDP by $1 trillion in my model, right? Government spending was increased by what? We increased government spending by 2, right? We increased government spending by 2. Now, the ratio of these two, 1 divided by 2, is 0.5. And that is the government spending multiplier by definition, right? By definition, the government spending multiplier is the increase in GDP that results from an increase in government spending, holding it all else constant. So we're dividing this number by that number to get this government spending multiplier, which equals this value here, not by coincidence, but by theory, right? Now, the 0.5 is hard to interpret, right? So 0.5 is hard to interpret. By itself, 0.5 is hard to interpret. The multiplier is hard to interpret. So the multiplier is the change in GDP over the change in government spending. So I'm going to make this number 2-part and divide it by 1. When I divide 0.5 by 1, it's still 0.5. Because the multiplier is 2 parts and this number is 2 parts, it's easier to interpret this value. So the numerator is the increase in government spending. The numerator is the increase in GDP, and the denominator is the increase in government spending. So if we increase government spending by $1, the multiplier says we're going to increase GDP by 0.5. So that's what we're going to answer here. The multiplier implies that each $1 increase in government spending, the denominator, causes real GDP to increase by the numerator, 0.5. Okay. Please have this. I'm going to reopen this assignment. Please have this lesson completed before we start class next Thursday. I'm going to reopen the due date.